All right, we're live.
Everything is bad because it's three decimals.
No, that's my sock. Man, I don't know. Are you guys getting like, I don't know. I'm hoping the video works because like it's not, I feel like my internet's going in and out. It's like really slow and clicky.
So is the video working then?
It says it's broadcasting. So fingers crossed that it stays working.
Yes, hopefully. All right. Okay, you guys ready? Okay. So, find the margin of error. So the margin of error is that's what like the M stands for, right?
No. Oh, the M. I thought you said like, yeah, M.
M, okay. So it's the standard deviation divided by the square root
Of N, just
times 2, right?
The margin of error? The margin of error
is the Z times standard deviation over the square root of the sample size.
What? Say that again?
Margin of error is the Z score of 90 percentile, which is 1.645. I don't know if you did all the homework and stuff yet.
Yeah.
Standard deviation divided by the square root of N to find margin of error.
Okay. Okay. I said it wrong. Sorry.
I was like, no. I was very careful to learn this because it confused me at first. I'm like, I did a lot of schoolwork today. My head is mush.
So what did you guys get?
Hold on just one second. I'm still doing the math. Are you guys finished?
Mm-hmm.
So I got 16.45.
Really? 16.45? That's what it should be, right? It was only times 10, so you just moved the decimal, yeah?
Yeah, because it's 50 divided by 5, which is 10 times the...
Three decimals, so I put a 0 at the end. Because picky about the decimal places.
Yeah.
So do you just put a 0 at the end then?
So it's 16.450 because it says round to 3 decimal places. But it was a 10.
Just one second. I'm going to go to my calculator so that it has like the actual square root of, no, the square root of 25 would have been that though. Yeah, it's still just 16.545.
Put a zero at the end because it says 3 decimal points. That's all I was saying, because it marks it wrong if it's not. She has it in there that it marks it wrong. Were you at that meeting where she was talking about that? You forgot the negative. Spaces, you got it wrong. I'm like, I volunteer.
Okay. So a point estimator gives one specific value as an estimate of a parameter. So I don't like the way that it's worded.
What's the second one? The sample mean is technically the point estimator of the mean.
Mm-hmm.
It's the mean that you use. In my opinion. It could be anything else.
Wait, I couldn't hear what you said, Shauna. It like went out.
Did it? I'm sorry. I said I chose the second one. Sample mean is a point estimator of the mean, because that's what it is.
Yeah.
Take my word for it. It's something else.
Hey, Zach, can you close those blinds, please? Sorry, the sun's like shining right in my face.
You're good.
Thank you.
You guys go for 5?
So with the point estimate, that's where you just do the equation, right?
The point estimate is the same thing as the sample mean.
Oh, it is? I'm sorry, this lesson confused me so much. I tried to do it last night, and it confused me.
I remember that from the video. It was one of the first questions we did.
Yeah.
X, the sample mean, is also the point estimate.
So it's 526.
And the z-score is called the critical value when you're doing these equations, just in case it says that somewhere. It's 526.
So then for number 6, let's see. So this,
you know how to find the z-score using the percent value in the area on the applet?
yeah, so you put, so like this one's 95, so you put 0.95 in the area, right?
And then you just do the middle area, just the middle.
Just the middle.
And it'll give you the score.
Wait, are you guys talking about number 6? Sorry, my computer keeps cutting out. Like I must not have the best internet or something right now.
So you shade the middle on the probability applet.
Yeah, applet. Then you just
95.
And you just put the 0.95 in.
So it's 1.960.
That's what I just got.
So you use the 1.96 equals Z, obviously, to find the margin of error. Same way we did in number 3.
So I got 27.685.
I got.
Sorry, I'm doing it. Okay, say that again because I think I got the wrong thing.
27.685.
Okay, I got 9.656. Okay, what am I doing wrong?
Take the standard deviation 113 and divide it by the square root of 64, which is 8. And then times it by your 1.96, and that's the answer.
Oh, I was using N instead of, or I mean, I was using X instead of N. So I did like 526. Okay, that's why.
Which you still need to get the lower and upper limits. So.
So to get the lower limit, we take the sample mean, which is the 526, and we go 526, subtract the 27.685.
Correct.
But then you would do the same equation, but you would do the 498, right?
498.315.
Yeah.
Because it's the 3 decimal places. That's really.
That's the answer to number 7, right? Is the 498 through 15? Because that's the lower limit.
Yep.
And then the upper limit is just the 526 plus.
Yep.
Which is 553.685. So number 9, I remember this one. Number 9, if the sample size increase, the width of confidence decreases.
Yeah.
I wrote that down in my notes.
So wouldn't there be no change because it doesn't, because it's not really the confidence interval that changes it, it's the it's just the width, right?
Wait, what is she changing it from?
As confidence increases, the width increases.
Oh.
The
Just changing it from
level of confidence increases, so the width increases.
It goes where it goes. Like it decreases, it decreases, it increases, it increases. They go.
This one we're gonna have to work backwards, right?
So for this one, you would find it's that equation. It's like the z times the standard deviation
Over the square root of n.
Divided by m, yeah.
Yeah.
Squared.
Squared, yeah.
Did you guys get 246?
Hold on one sec. So like the way you guys found it, is it you're trying to solve the equation that's 50 equals 1.960 times 400 over the square root of n? Or am I like way off?
Which number are you doing? 11?
Yeah.
Are you doing 11 for the sample size?
Yeah.
You're going to take n because you're trying to find the sample size, and you're going to take z times standard deviation over margin. And when you get that number, you're going to square it, and that equals the sample size.
But we don't know the n, though, do we? We don't know the sample size.
Finding for n on number 11.
Yeah.
Yeah, so we're like, the margin of error we know is 50. So 50 is equal to the 1.960, and you got that from the 95%. You put that in the applet, and you get the 1.960 times the standard deviation, which is 400, over the square root of n.
Formula for n. N equals z times sigma over margin of error squared. So you're going to take 1.96 times 400 divided by 50 and square it to get the sample size. And you always round it up because you can't get like a point of a person.
Oh. So you're just using the same formula, but instead of the square root of n, you just do the margin of error squared? I'm sorry, I'm struggling with this right now. It's 1.960 times 400 divided by 50 squared.
Yeah. But divided by 50, do that first, and then square the answer.
Oh, and then square the whole thing.
Like it's in brackets, and the square is on the outside of the brackets. They don't write it that way.
Gotcha. So did you guys get 245.862?
Yeah, you rounded up to 246.
Yeah, you round it up to the nearest whole number up. So it's 246.
Gotcha. Okay, sorry about that. That makes a lot more sense now, though. So thank you.
You're welcome.
So this one's 110964, right?
Which one?
412.
That's the same as you've been doing it. You just need sigma, which you have.
Mm-hmm.
You need C, which you have. 95% is 1.96. Stays the same. Divided by N, and gives you 36 is your N.
Oh, wait, sorry, I forgot a step.
Let me know what you get for margin of error.
Okay, I think I got it.
What'd you get for margin of error before you do the lower limit?
11,998.46666.
Yep, that's what I got. Okay, good. Because otherwise the other numbers are wrong.
Okay, and then for the lower limit, we just subtract that from.
Take the mean sample minus the margin of error.
So it's the 100,000 minus that?
It's the X, the sample size, the X with the line over it is 111,000.
Yeah.
X minus the 11,98467.
Yeah, so you get 99 and 1
Yeah.
and 2. 99,002. And then the upper limit
and then the last one's all the above, isn't it?
Yeah.
Okay.
Allison, what'd you get for 13?
For 13? Sorry, just a second. I already submitted it.
Did we get 100?
It says I didn't get 12 and 13. I must have did those wrong then. That was the only ones though.
Okay. What did you have for 13? Just out of curiosity. Because if
Sorry, say that again.
got it wrong, so.
What?
If we have the same thing we got wrong is what I'm saying.
Yeah, I don't, let me see. I got, I don't know if, I don't think I did this one right. I got, let me go scroll down. I got 113,826. I don't think I did that right.
For which one?
For 13, that's not right. So let me redo this.
What'd you get for 12?
The same as you. What'd you get for 13? Like, how'd you round it?
For 13, I got 122,998.
Put 98 instead of 99?
Yeah, because when I did it, I got 122,998.46666. So, do you want me to submit it real quick and see what we got?
Yeah, I'm just curious. Well, I'm sure she'll allow one or two above or below, but just in case.
Yeah. All right, so I'll submit it.
Because it's 0.467, so I didn't know. Do I take the 6 and make it a 5 and that makes it a 9 or not?
Yeah, it's 100%.
So did you get those right then?
Yeah.
It was right for with an 8 though. I can change that to an 8 instead of a 9.
For 13, I got 122,998.
Yeah, I rounded it up one because of the 467. So,
Yeah.
but if you got, then I'm good.
And then 12 was the 99,002.
So tell me how you got the upper. I don't know why I'm getting that one wrong then.
You take the sample mean,
yeah,
and you add the margin of error.
Okay. Okay. Good job, guys.
Yay! Everybody got 100. Sweet.
Are you tired?
Oh.
I was gonna say you seem like you're really tired today.
Well, go have fun, Rachel. We don't want to keep you.
No worries. All right, so I guess we'll see you guys on Thursday.
Okay, see ya.
Bye.